For what value of the constant c is the function f defined below as a piecewise function continuous for all real numbers x from minus infinity to infinity? We are working with a piecewise function. F of y, don't be scared of this notation, it means that the inputs are called y, equals to y squared minus c if y is less than 6, and then cy plus 2 if y is greater or equal than 6. It's a little bit confusing when you start working with piecewise functions, so I will show you how I like to teach it. Let's call the first line equation number 1 and the second line equation number 2 and sketch the situation. So the gap or a break is happening at 6. Before 6, we're working with equation number 1 because here y is less than 6. By the way, this is axis called y-axis, which means the input was renamed as y. It's basically like t time, y can be temperature or whatever you want. Now, when y is greater than 6, we using equation number 2. It says it here. What is happening at 6? At 6, we also use equation number 2. So this is how it looks. Moreover, equation number 1 is a parabola. Thus, somewhere on before that, we're walking on the parabola, like so. And then we stop, and at 6 and after 6, it becomes a line, like so. It may be increasing or decreasing, depends on the c, which we need to find. Moreover, both equation number 1 and equation number 2 are continuous. Parabola is continuous everywhere, and line is continuous everywhere too. So the only point we need to check is point 6. Solution. Y squared, so let me call it f of y. Y squared minus c is continuous for all x. For all x. It's a parabola, right? F of y, which is cy plus 2, also continuous for all x. Thus, we only need to check, a suspicious point, which is, why keep us saying x? Did you notice that? The values are not x in this case. So let's fix that mistake. It's input y. So we need to check what's happening at y equals 6. What is happening at this point? Do they even meet? And if they meet, that there is a hole or not? What if they don't even meet? What if the line is shifted up and now there's a jump? So we need to figure out what is actually happening there. To check that, as you have guessed, I hope, you need to figure out limits. What is happening when this function, when the input of this function, which is not x, by the way, I will be doing it probably for the whole video, approaches 6 from the left, f of y equals what? Then, what is happening when y approaches 6 from the right? That will give us idea about the limit itself. If the limit at 6 exists, f of y, and then we also need to figure out what is happening at 6, which is going to be very helpful in a second. So then we need to figure out what is happening at 6, like so. These two all numbers are here, should be the same. Only if they're all the same, those values, the function is continuous, because basically the definition of continuities are those two last lines. They should give you the same value. So let's do it. Well, the function has two equations because it's a piecewise function. Which equation do we use when we work with the left limit? 6 from the left means, let's look at the sketch. My inputs are approaching 6, but they are less than 6. Being less than 6 means I need to use equation number 1. Thus, I'm actually working with the limit as y approaches 6 from the left of the function y squared minus c. Now you can forget about the left part of the limit. The left part of the limit just helps you to choose the equation to work with. And you can substitute 6 into y. And this is the answer for the left limit. Put this in the box, it will be important. Repeat for the second equation. When inputs approaching 6 from the right, it means the inputs are always greater than 6, but close to it. That means we're working with equation number 2. That means we need to substitute 6 into the equation of the line this time, which is c times y plus 2. That means we will have c times 6 plus 2. Put this in the box. Finally, what is happening at 6? I'm gonna skip the limit for a second. At 6, which equation should I be using? As I mentioned before, find the equal sign or the closed bracket. Closed bracket means at 6. And we already agreed that at 6, we need to use equation number 2 again. So at 6, I'm using equation number 2. Again, let me put it in green. And we already calculated that the answer is c times 6 plus 2. Thus, these two numbers are already the same. The only thing missing is that these two equations must be the same. For the limit to exist and to be the same value as f of 6, I need to make sure that the c we're looking for satisfies the equation. 6 squared minus c equals c times 6 plus 2. And we solve this equation. It's a linear equation. Collect all the unknowns. Unknown here is c. I will collect them on the left. Minus c and minus 12c equals 2. 2 minus 36. Negative 13c is negative 34. C is negative 34 over 13. Is that correct? I'm checking quickly with my notes. 36 minus 36. Yeah, it looks correct to me. So it's going to be negative 34 divided by negative 13. Thus, it is 34 divided by 13. And that will be the solution for the c we are looking for. Well, I'm a little bit confused because my solutions don't match what I just found, but I think I did good. So, you know what? Let's use my solutions instead. Minus c. Oh, I see. Why did I put minus 12? Here you go. I found the mistake. This was 6c. So it's going to be minus 7c divided by minus 7. Fixed it. Thank you for letting me know. I knew that some of you saw it right away because you're paying attention. Very good. Answer. Well, if we just ask you to find c, you did it. Good job. 34 over 7. But also we now can write down how the function will look like. F of y will look like so. It's going to be y squared minus 34 over 7 and 34 over 7 times y plus 2. The first equation happens when y is from minus infinity to 6, but not including 6. And the second equation happens when y is from 6, including 6, to plus infinity. This function is continuous for all inputs y. I decided to go ahead and get a sketch of this function. As I mentioned before, from the left of 6 we're working with the parabola, and from the right of 6 we're working with the line. Here you go. Here is 6. Here is the point where they meet. On the left from 6, but not including 6, we are walking on the parabola. So from minus infinity to 6, the outputs are located on the parabola. Then they stop. On the right from 6, we are working on the line, or walking on the line, if you imagine as a hike. So this is how it looks. And we made sure that not only they meet, so the line is not over here or not over here, but also when they do meet, f of 6 is the same value. That made this function continuous. So when I put a pencil on the graph of the function, I don't have to take my hand out of the paper to keep drawing it. Thus, we made the point 6 a point of continuity. The whole function is continuous from minus infinity to plus infinity.